Okay, so this time we're talking about line equations, and you're so used to your precious y equals mx plus c. It's quite, hard at the beginning for students to kind of just drop that. Like, it's useful to know y equals mx plus c, but actually in A level we need to use y minus y1 equals m, x minus x1. It's not need to, it's better in the sense that if you make any mistakes in your y equals mx plus c, you can lose more marks than if you do use y minus y1 equals m, x minus x1. And also, it takes more work to rearrange something to look like that than it does to this. This is actually very easy to use when you know how. So you know how to find the gradient already. That is our m. And the other thing you need to know is what's this y1 and x1 mean? That just means a coordinate. So just like for our other video where we said, A was our x1, y1, and B is our x2, y2, you just literally need to plug in the coordinate as you see it. So, we could get into the y's and things like that, but I kind of just feel like let's just go for the formula and yeah, let's just start with the formula. So we know that m is change in y over change in x. We did that from the previous video. So y2 is 2, take y1, so that's minus 1, over minus 1, take 3. So 2 minus that is 3 over minus 4. So our gradient was minus 3 over 4. So already, to find the line equation, we've got the m. So y minus equals m is minus 3 by 4. X minus, right? So this y and this x means any general point x and y. It doesn't matter what it is because it can be any point x and y. Whereas y1 and x1 are fixed points. Okay, I think I will talk about that more in a second. So in this case, y1 is minus 1, so minus 1, and x1 is 3, so 3. So our answer is y plus 1 equals minus 3/4 over x times x minus 3. Now why this is useful is that is actually in itself a perfectly acceptable answer. Okay, but the question may say write this in the form ax plus by plus c equals 0, where a, b, and c are integers, for instance. It may ask you to put it in the form y equals mx plus c, but more likely it will ask you to put it like this, or you can just leave it like that. The easiest way to make it look like this is just to times up by that denominator, rather than multiplying out this bracket. It's so much easier to do that. It takes a lot less work. We don't like dealing with fractions really. So if I times by 4, we get 4y plus 4 is minus 3 times x take 3. So you just need to multiply out that bracket. So 4y plus 4 equals minus 3x plus 9. Bring everything over to the left. So we get 3x plus 4y minus 5 is 0. So we have it in that form where a, b, and c are integers. So in other words, whole numbers. Briefly, what am I talking about here? So remember we had a here was 3, 1, I believe, or was it 3 and minus 1? Yeah, 3 minus 1. So a is 3 minus 1, and b was minus 1, 2. Yeah, just double check that. Cool. And then we have a line going through that, connecting them, so like this, okay? So you just need to know, essentially, that every single point on this line could be called, has a corresponding xy. So you can see that that p is the general xy. So at this point, I can see that in this case, p is a half, x is a half, and y is like 0.8, let's say. But if I said, no, actually, I'm going to make this my p, then this is minus 2.2, and y is going to be 3, right? So in the formula, y take y1 equals m, x take x1, this y and this x means this general point p, where p can be an infinite number of options along the line, because a line is just an infinite number of points collected up, okay? And what anchors those points, because essentially the gradient, right, means, can you see this parallel line? This line is parallel to that blue line, right? It's got the same m, and it could have the same general p and y, like x and y, right? The only thing that makes it distinctly this line is this anchoring point of one of the known coordinates, either b or a, right? If we didn't have b or a, then how do we know if it's this line parallel to it or this line parallel to it? You don't. You need an anchoring, a fixed point to say, no, that's the line we're talking about, okay? But let's actually do the examples to make this so you actually want to know how to do stuff, right? So we're going to write the formula, y minus y1 equals m x minus x1. And straight away, without even doing any work, I know that y1 is minus 3, and I know that x1 is minus 4. So we've done that bit already. Now we just need to find the gradient. So m is y2 take y1, x2 take x1. So m is minus 1 plus 3, so that's 2 over 8, so that's a quarter. Can you see the line is actually done immediately? So much quicker than y equals mx plus c, in my opinion. And then again, if the question asks for you to put it in ax plus by plus c equals 0, for instance, times by the denominator. So 4y plus 12 is one lot of x plus 4, multiply out the brackets, move it all over to one side. So 4y plus 12 equals x plus 4, so therefore x take 4y, take 8 is 0, and that's job done, okay? Whereas this part C, again, let's go quicker this time. So y minus y1 is m, x minus x1. We know what y1 is, it's 11. And we know what x1 is, it's 10. It doesn't matter if I use this coordinate b, it doesn't matter. You can use y2 and x2, literally doesn't matter, you just need one point to make a line. So now we just need m, so we need the gradient and 1 point to make a line, okay? So y2 take y1, x2 take x1, so minus 5 over minus 16, so that's 5 over 16. So your line is y minus 11, 5 over 16, x minus 10. And if they don't ask you to write it in any form, that is a perfectly acceptable answer.